As you have learned, there are various different strategies towards finding the limit of a function. And you may be wondering, why in the world do you ever have to use limits in mathematics? In today's video, you will learn a very important use for limits in determining the slope of a tangential line. Before we dive into today's discovery, let's quickly recall what a slope of a tangent is. Here we have a graph with a function f of x. The definition of a tangent is when a line meets a curve at a single point. We know that this tangent line has a particular slope, which is also known as the instantaneous rate of change. So how can we use limits to determine the slope? The general definition of a slope is given by the equation m equals delta y over delta x, or m equals y2 subtract y1 all over x2 subtract x1. However, in order to use this equation, we will need to have two definitive points on a slope. The catch here is that by definition, the tangential line only touches the curve once. So if we want to find the slope at the point indicated here at x, y, we will need to have two distinct points. How can we accomplish this? Let's take a closer look. Let's say we want to find the slope on this parabola at the target point indicated here. One method of determining the slope is to first find 2 points that are close to our target point. In this case, we have one point to the left of the target point indicated by a purple dot and the point to the right of the target point indicated by a blue dot. Now we can determine the slope that passes through these 2 points. In order to find the slope at the target point, we just have to approach the target point from both sides. Now, we've determined the slope of the tangential line at this point. Although this method works, the math involved to calculate the limits coming from both sides of the target point is extremely tedious. So let's simplify the calculations a bit. Instead of determining the slope with 2 moving points, let's make one point stationary, which is at the target point, and only determine the limit as the second point approaches the first point. Since the first point has now become the point we want to determine the slope, we can now call this first point x, y. Also, since this point lies on the curve f of x, we know that y1 equals y equals f of x, and x1 equals x. And we can sub these two equations into the slope equation. We also know that the second point, x2, y2, also lies on the curve. The trick here to determine the slope is to simply determine the coordinates of x2, y2 as it approaches x, y. We know that the difference between x and x2 is by an arbitrary amount, delta h. In other words, delta h is equal to x2 subtract x. If we rearrange this equation for x2, we can now use this new equation to sub back into x2 and y2. And sub this new equation back into the equation of the slope. Then, clean up the first equation. Now, to find the slope at the point x, y, we have to bring the point x2, y2 to x, y. We can accomplish this by making delta h approach the value 0. Thus, we are able to find the limit as the point x2, y2 approaches x, y. As a result, we create this equation, which is also known as the first principles method of finding the slope. We will now demonstrate how this equation is used to determine the slope at any given point. Let's say we want to find the slope at a particular point on this parabola. The equation of the parabola in this case is y equals x squared, and the point of interest is at the coordinate point 1, 1. We know that f of x is equal to x squared, and f of x plus h is equal to x plus h quantity squared through simple algebra. We then sub these two equations into the general equation and solve for m. To simplify the equation, we first expand the exponents, then FOIL and collect like terms. In this case, the x squares eliminate each other and simplify to this equation. We then factor out the h from the numerator and then divide out the h from the numerator and denominator. When we solve for the limit as h approaches 0, we find out that m equals 2x. M equals 2x is actually a general equation for the slope throughout the entire parabola. We can sub in whatever value of x that we want and then solve for m. In this particular example, we choose x to equal 1 since we are interested in the slope at the point 1, 1. So we sub in x equals 1 and solve. We come out with the answer m equals 2, which means that at the point 1, 1, the tangential line at this point has a slope of 2. If we want to find the slope at the point 0, 0, we again sub in x equals 0 into the general equation of the slope and solve for m. In this case, m equals 0, which means the slope of the tangent at the point 0, 0 is 0. We hope that this video has been beneficial and has helped clarify some misunderstandings in determining the slope of a tangent using first principles.